We are given a block that is sliding from rest on a plane inclined downward 30 degrees from the horizontal. The vertical distance of the block from the level ground is 6 meters. Given a coefficient of friction of 0.25, we are tasked to determine the velocity of the block as it reaches at the bottom of the plane. And to solve this problem, let us draw our figure for this problem. We have an inclined plane inclined at an angle of 30 degrees and a block on the top that is at rest, and the vertical distance of the block from level ground that is equal to 6 meters. And the coefficient of friction of the surface is 0.25. And after some time, the block will tend to slide down from this point to this point here, and we are tasked to solve its velocity as it reaches at the bottom. Now we need to solve for the distance from here to here, since we will need this to solve for our work and energy. Using the sine function, that is sine 30 degrees equal to the opposite side of 6 meters divided by the hypotenuse. Let's call this d. So d is equal to 6 meters divided by sine of 30 degrees, which is equal to 12 meters. Now to solve this problem using work energy method with the summation of all positive work possessed by the object minus the negative work equal to the final work possessed by the object. Now for the positive work possessed by the object, it is in the form of the force due to its own weight that would tend to cause the block to slide down, that has a value of mg sine theta. And for the negative work that would tend to impede the speed of the block as it slides down on the inclined plane, it is in the form of frictional force that has a value of mu times the normal force of mg cosine theta. And what counts as the final work is the kinetic energy of the block in terms of its velocity, that is a value of 1/2 mv squared. So we have our positive work of mg sine theta multiplied by the distance d of 12 meters minus the negative work due to friction, that is mu mg cosine theta times the distance d, equal to the final work of 1/2 mv squared. Now notice that m cancels because it is found in all expression. Therefore, what is left for us to solve is just v, since the remaining variables are just given. So we have g equal to 9.81 meters per second squared times sine of theta of 30 degrees multiplied by distance d of 12 meters minus mu of 0.25 times g times cosine of 30 degrees times d equal to 1/2 v squared. Now let's put this into our calculator. We have 9.81 times sine of 30 degrees times 12 minus 0.25 times 9.81 times cosine of 30 degrees times 12 equal to 1/2 v squared. We get v equal to 8.17 meters per second. And that's our final answer.